In this lesson, we are going to see how we apply the idea of partial fractions into integration. So, please don't forget to subscribe to the channel. Now, this question is saying, evaluate the following. They give you this and they give you this. You can hardly integrate this without using the idea of partial fractions. So what you do, you always first express this function into partial fractions, then you can easily integrate as we're going to see. So what we do now, to integrate this, you first express this into partial fractions. So we consider now the whole of this function. So you say consider now the whole square. So this one is linear and this is repeated. And so if they are this is linear and this is repeated, we saw how we handle them. This is repeated but linear also. So this one is identical equal to a over x plus 1, then plus, we say this one start with the power 1, so b into x minus 2, then plus c over x minus 2, the whole square. Now after doing this, now we say the LCM, you see this is contained in here, so the LCM is this, and is this. So now R4 x minus 5 will be equal to a. You get this, you divide it here, because the LCM is going to be this times this, because this is inside here. So when we get this divided by this, you remain on this, then this times this, square then plus b into, and we get this and divide it here. One bracket is going to go with 1, so remain with into x minus 2, then plus c, and we get this and divide it here, then all of this goes to remain with x plus 1. So now if you want to get a, it's not which bracket is a missing. It's not that a is not having this bracket. So it's when x plus 1 is equal to 0. So if x is equal to, well, if I want to make this and this, I say when x is negative 1. So when x is negative 1, so here I'll be having negative 1 times this, which is negative 4. So I'll be having negative 9 equal to, I'll be having a into negative 1 minus 2 the whole square. This will be 0 and this will be 0. Because negative 1 plus 1 is 0 times 3 is 0. So see that this one, I have negative a equal to, this is negative 3, when square it gets 9a. And start from here, 9a is a negative 1. So after getting a, I'm missing b and I'm missing c. So to get one of the two, now to get c, which bracket is missing on c? You see the bracket of this, so you equate it to 0. When I equate this to 0, x minus 3 equal to 0, I get x as 2. So to start when my x is 2, I'll be having here 2 times this, that will be 8, minus 5, that will be 3, equaling 2. When I put here 2, it will go to 0. When I put here 2 minus 2, 0 times this is 0, I'll be having 2 plus 3, which will give me, 2 plus 1, which will give me 3c. So that my c will also be, will be a 1. So that now we are only missing a b. So I can't say, because I've used already a negative 1 and I've used also a 2, I test any simple number. So the simple number we can use is a 0. When I say when my x is 0, you use simple numbers to get the remaining. If you have the 2, you use simple numbers to get the third. So like 0, when I put here 0, I have negative 5 equaling 2. When I put here 0, I have negative 4, negative 2, but squaring to give me 4n. When I put here 0, I have 0 plus 1, which is 1. This is 0 minus 1 is negative 2, so negative 2 times 1, I get minus 2b. When I put here 0, I get plus c. I know what my c is. My c is 1. So from here, I see that my negative 5 is equaling to my 4a. 4, a is this, so it's negative 4, because a is 1, minus 2b, which I am looking for. Then c is 1. So you see, this is going to be negative, this is going to give us negative 3 This is going to be negative 4 plus 1 is negative 3. When I take it this side, I have negative 2 equal to negative 2b. And so from here, my b is 1. When you simplify, that is that your b is 1. So now, you write this as, of course, now from here, start now, my 4, x minus 5 over x plus 1, x minus 2 the whole square. Instead is equivalent to our a is negative 1 over x plus 1 plus b, our b is 1 over x minus 2 plus our c is also 1 over x minus 2 the whole square. I'm substituting it here. Now remember we are adding the integral. So now to integrate this, you integrate also this without. So now we integrate. Now 4x minus 5 over x plus 1 squared with respect to x. Now this is going to be, means that you are going to also integrate this separately, also integrate this. You have introduced an integral side of the x, so you introduce it also there. This will be, you can remove this constant and negative, okay. Negative 1 over x plus 1 dx plus 1 over x minus 2 dx plus 1 over x minus 2 the whole square dx. Because they have introduced it here, so introduce it without. Now, so the whole of this will give us, when we integrate this, we get this negative out, then natural log of x plus 1, then plus, when we integrate this, we get this, these are linear functions. So natural log of x minus 2, then instead to integrate this, we have seen how to integrate this. You take this up, you increase the power by 1 by the new power, so you get negative 1 over x minus 2, then plus the constant of integration. We are going to, after this one requires when we have covered the idea of integration. So go to integration, you are going to see how we integrate all of these functions. So it means that now, the all of this are including the constant of integration because we don't have any limits. So now the all of 4x minus 5, we can go and simplify this. Dx is going to be, you see, I can use properties of logarithm. So this minus this, the same as natural log of. You can leave it there or you can simplify it like this. You make this minus this. When we are subtracting, we divide. So plus 1, then minus 1 over x minus 2, then plus constant of integration. And that will be, they give you limits, you just substitute your limits. So that's it. When I come out to, I also consider this bracket. Remember, our 2 is the integral of 5, is it plus? Yeah, plus 3x over plus 2 dx. Now from here, I consider the fraction there, the rational function. Now I'm saying this is linear and this is quadratic. So I say, let this be according to, this is linear, so it's a over x minus 1, then plus. This one I'm going to see, so this one is quadratic and unfactorizable. It's factorizable, we express it into linear factors. Because it's quadratic, the remainder has to be linear. So bx plus b, the whole over x squared plus 2. The LCM, we get this times this. So you have 5 plus 3x will be equal to a. Get this, divide it here. So when you multiply this and this, you get this. So this is the LCM. So this goes here. When you get this, divide it here, and then like this. Then this times this. Then plus b into. When you get this, and divide it here. This goes remain with this and multiply it there. Now this and this will multiply these two, they are going to cancel with this. We have seen that in lesson 1. So if you want to get A, which bracket is missing here? This is the bracket that is missing here. So you equate this now to 0. When you equate this to 0, you see that x is going to be 1. So when x is 1, I have here 8 equaling to 1. 1 plus this, which will be a 3. Is it? When x is 1, yeah, it's going to be 3. Because 1 squared is 1 plus 2 is 3. When I put here 1, it will be 1 minus 1, which will be 0, so the order go to 0. So that my a here is going to be 8 over 3. As simple as that. Now, what's remaining here is I also come and I get, now you see to get this b, I need to get this to 0. So if I say this one is 0, so if my x is 0, why? So that I can make this constant b, capital B. So when it's 0, here I have 5. I have my 5 equaling 2. Here I have 0 plus 2, which will be 2a. I mean times 2. Then here I'll be adding 0. So I'll be adding b here plus b into 0 minus 1, which will give me negative 1. But it's decided already, my a. So if I'll be adding now 5 equaling to 2 into 8 over 3, then minus b. I take b this side, and now my b will be, this will be 16 over 3 minus, I bring this side, 5. This side is 16, then take this side, it becomes positive, bring this, it becomes negative. Of course, multiply there, so this will be 15, 16 minus 15, so that our b will be giving us a third. So if b is a third, that's what I mean with capital B. How do I get capital B? Is by saying if our 2, if I reduce this bracket to 1. So I can say when x is 2. So when x is 2, this will be 2 minus 1, which will give me 1. So I'm reduced to that. So when my x is 2, I have, this will be 2 times, I have 2 times 3, that is 6. So here I have 11 equaling 2. My a, first of all, my a is 8 over 3 into, this is 2. So 2 squared, that is 4, plus this I have 6. Then plus my b, which I want. So I'll be adding 2b, because my x is 2, plus b, which is a third, into, when I put here 2, it has reduced to 1. So now, so when I use this, I get this as a 2. So 2 times this, I have 16. When I bring it this side, you see that I have, okay, 11 equaling 2, this by this, 16. 16, when I see this will be giving me now, plus a third, then plus a 2b. So when I take everything this side, this one first of all is going to be less. So when I take this side, I have negative 5. So I take this side, negative 5. Then minus a third equaling to 2b. When you simplify, this will be negative 15 minus 1, which will give me negative 16 over 3 equaling to 2b. Divided by 2, is that our b. Negative 8 over 3 will be going to our b, like that. So if we have everything, now you come and you write this. So now our 5 plus 3x, the whole over, plus 2 is going to be our a, which is 8 over 3, plus our b, is negative 8 over 3x, plus our c, our small b, which is r sine the whole over x plus 2. Now from there, I can easily integrate. If we integrate, this is the x will be. Now since it's going to be a constant, I pull it out. So 8 over 3 integral dx over x minus 1. I'm going to introduce the integral sign and the dx. So you see that this one I can easily separate. So when I separate this, we have seen now we can easily separate this in our previous lessons. So this is going to be minus 8 over 3. It's going to be a constant. Here remaining with x over x squared plus 2 dx, then plus. As to separate this, I'm having 1. So this would be this divided by this and this divided by this. So this will add into integral dx over x squared plus 2. In the previous lessons, we separate this. Remember, the whole of this. Remember, you can express this into negative 8x over 3 over x squared plus 2, then plus 5 over x squared plus 2. That's what I'm doing here. After this, I integrate this and this. That's why you see this is the constant, I pull it out. Then this is a value, I pull it out and I also integrate it. Okay, this is going to be 8 over 3. Integrate this to get natural log of x minus 1. Here we start, this is the fraction, it's derivative. This one. We have seen this one, but you start here, we are missing a 2. So what do? We bring a 2, we create a 2, and we remove that 2 as a half. This 2. That means when I differentiate this, I get 2x, which is already there. So introduce a 2 and we remove it. So this and this, I'll be having negative 8 over 6. So you can reduce. Then this will be natural log of x squared plus 2. Then plus r squared. Then this one you see, it's in the form we said. Of course, remember, we said when we integrate the x over x squared plus a squared, this will become, which some people write as dx over x squared plus x squared. This one becomes 1 over a, then tan inverse of x over a. It is. So now is that we need this as this as our credit as a square. So that here, remember our 2 is the same as root 2 squared. So it will express it in this form, as simple as that. So that here, this x is here. So here, my I need to create a root here. If I bring here a root, create a square. So this will be square and root 2, so that I don't change anything. So times 1 over root 2, then tan inverse of x over root 2. And so simplify everything there, and that will be the answer. So anyway, that will be the answer. You just add a constant of integration. You can reduce this to whatever you want. That's the maths. That's how we handle. So that's how we apply partial fractions in such integrals. I wish you well.